Good evening, everyone. Good evening from Jeddah, Saudi Arabia, and good evening from Manama, Bahrain. This is Nawal Al Hamwi. Firstly, I want to thank our sponsors, StreamYard, for sponsoring our event. We couldn't have done it without their help. So thank you, StreamYard, once again for helping the community. I want to thank Khulud Al Banna and Munib Yunus for because they will be moderating the chats. So if you have any questions, please don't hesitate to throw your questions in the chat area. So today we will be talking about how do the engines of the games work under the hood. So we have Ameen Al-Tajir from GDG Manama. Ameen is the CEO of Infiniteware. It's an artificial intelligence company that provides products and services to several clients across the globe. Infiniteware has been working with large clients such as Saudi Aramco, STC, and the government of Bahrain. Amin has been in the software business for more than 15 years. And you can find Amin Al-Tajir on social media. We will write out his social media handle. So, Amin, the show is all yours. All best of luck.
Thank you, Noel. Thank you guys very much for having me in here. Such a pleasure to work with GDG Jeddah. Never done it before, but this is the first time, and I'm super and probably extra, hyped for this. And yeah, thank you very much again. We normally do these sort of sessions for the game development community. However, we wanted to do this here for GDG Jeddah, for a change. And yeah, super excited. So let's go ahead. Okay, so the name of my talk is understanding game engines, or how do game engines work from the inside. Let's go for it. So a bit of a brief introduction about myself. My name is Ameen Al-Tajir. You can always access my content at ameenaltajir.com, or you can always find me on social media at Ameen Al-Tajir. So I used to work for Saudi Aramco for a very long time. And the funny thing is, I got access to Saudi Aramco given my game development background, which was the portfolio that I used to have online back on my game development website, which was called ps3code.com. As you can probably tell, very influenced by the PS3 tech. And currently, I have my blog at ameen.ai. And you can also find our work at Infiniteware at infiniteware.com, where we have a lot of work relevant to the space of AI. Some of the clients that we have, or Saudi Aramco by far is the biggest, and we have STC, UGB, Zain, and a couple of more. So we've been around for almost 10 years now. So there you got it. Okay, so at Infiniteware, we actually, because we are an AI business, we live by three values. The first one is we automate mundane or repetitive work. Second is we promise more intellectual bandwidth. And the third is we use real intelligence to make value. However, these are the things that make Infiniteware what it is. Okay. Now, for this talk today, we're going to have an agenda that is split into probably 3 or 4 parts, depending how you want to see it. The first one is we're going to have a tour on basically the common game engines, the popular ones out there, and we're going to have a look at what happens in terms of their duties, how they work. And then the second we finish that sort of generic tour, we're going to get into that detailed components sort of look under the hood, where we see the exact components that make up every single engine that you see out there. At the very end, we're going to have a bit of hands-on. So we're not going to be programming game engine code or so. But however, I'm just going to open one of the game engines that I really like. The source code is based on C++. So it might be low level. However, I'm going to take you by the hand to understand how it works. And so you can see things in action and understand how the whole engine really plays a huge part when it comes to making the game what it is. And last but not least, we can always finish with the QA. And that's pretty much it. Okay, enough with the paperwork. Let's go for it. So you probably have heard of the game engines out there. There are quite some, some popular ones out there. You have Unity, you have Unreal Engine 4, and now we're getting into Unreal Engine 5 also. You probably heard about Game Maker, which is a very popular game engine for 2D games. CryEngine, if you're a big fan of the the Crysis game. So yeah, there's a lot of stuff out there. And you as a game developer, you get to be very picky. I mean, what should I use exactly for my game? Which is the million-dollar question if you're coming into this game development scene. But yeah, the idea is there's a lot of variety, there's a lot of choices. And as a game developer, you have to really be super picky and selective when it comes to choosing the one that works well with your game. And we're going to get into that and the specifics of how you can choose and why would you choose one of the basically the game engines out there. Okay, so the ones that we just showed now were the public ones, or let's say the commercial ones out there, like Unity, the Unity engine, Unreal Engine now is becoming a very popular one. It was not that case before, given it was a private game engine and it was licensed in a very difficult terms, honestly. But now we still have internal game engines that are not very popular to the public, given that they are dealt with extreme secrecy or let's say confidentiality for different reasons, be it legal or be it IP specific reasons or so. So you have the Fox engine, which is pretty popular if you're coming from the Metal Gear Solid era, where a lot of people still remember the favorite game, Metal Gear Solid. You also have the Red Engine, which is the same engine that these guys used for, if I'm not mistaken, the Witcher game. Decima is one of my favorite engines, being used in Horizon Zero Dawn, and if I'm not mistaken, it's still being used in Death Stranding. You can probably check that out online to double check. And my ultimate favorite, which is the Naughty Dog engine by Naughty Dog themselves, the same engine that we used with Uncharted, the game series, and with The Last of Us 1 and 2. So there you have it. So we have two kind of game engines out there. We have the public ones that we saw in the beginning, things like the Unity engine, or I'm sorry, not this one, the Unity engine, the Unreal Engine, the Game Maker, and CryEngine, and so. So all of these guys that you can see here can be bought online, or you can probably just license them. However, for these guys in here, you have to be affiliated with those developers in order to get those. It's a private source code base, so not everyone can have hands-on on that on those engines, and there are specific reasons for those. Okay, so a lot of people ask themselves, okay, why are you so excited about game engines? What is so special about that? Well, the million-dollar question is, what is so special about those can be answered with those specific, answers that I have in here. The first one is a game engine really decides how your game is going to be played out in terms of performance, in terms of even features. So everything that you have in terms of vision for your game, in terms of game mechanics, the physics aspects of your game can all of these guys really are dependent on the features of the game engine that you're using for your game. So a good example is Game Maker, for example. So Game Maker is a 2D game engine. It's going to be probably very difficult for you to put 3D game art within the game engine. You have to do a lot of tweaks, but eventually you're not going to get a 3D game engine. You're not going to get a 3D scenery within the game engine. And so, and that is a very simple case. There are game engines out there that are specific to first-person shooters, FPS games, as you probably know. And there are couple game engines out there that really excel when we're doing platformers, regular games where you have to jump through platforms in order to proceed in the game. So what I'm trying to say here, there's a lot of specifics and nuances in understanding how game engines work, because eventually for a game developer, a game engine will really just, scope, your, let's say, the perimeter or the boundary of your ideas, your game design ideas. Okay, so before we chart into the exact components and the specifics of the game engine, let me show you exactly where game engines differ. The first one is eye candy, which is probably the most, let's say, attractive thing about games nowadays. So a lot of people just, by the mere watch of flicking at the screen, you can really tell that, hey, this looks like a nice game because of the eye candy. And so a good example is Horizon Zero Dawn, which is a very popular game that was released for the PS4. If we have Sony fanboys in here, I'm one of you guys, so don't get very scared. So yeah, Horizon Zero Dawn, as you can probably tell, has a very cool scenery. There's a lot of details in there, things like lighting, shadows, even the exact details of the art that you see here on screen. All of these things are dependent on the specifics of the game engine and the features of the game engines that we have out there. So yeah, everything that you see from art to animation, it's all handled within the game engine. So it's pretty much dependent on the features of the engine. A lot of game engines out there really excel when it comes to do 2D art. However, they can't, support 3D stuff. And there are certain game engines that really excel when it comes to doing, let's say, AI, but they don't have the, let's say, the other elements. Let's say something like sound, or even graphics. But in this case, graphics is a pretty big deal when choosing an engine. The fidelity of the art that you have on the screen really, really gets you to decide really well on the sort of game engine that you want on board. So a couple of images in here to show the fidelity that's driven by some of the engines out there. So Horizon Zero Dawn, this game that I just showed you here, utilizes the Decima engine, the one done by Guerrilla Games, which is a very popular game studio. And then you have here The Last of Us. A lot of talks on The Last of Us 2. We're not going to get into that. There's a lot of back and forth. However, nobody can deny how amazing the technicality behind The Last of Us, the graphics, the AI, and all of these things. But yeah, there you have it. The details on the hair, the details on the beard itself, the skin itself, how it reacts to the light out there. So yeah, there's a lot of details, that make up the graphics behind the game, and game engines are in the front of these things. And most of the game engines out there really, give a lot of focus, maybe more than 40% of their workload on the game engines, on the graphics aspects, because it drives a lot of, let's say, attractive. A lot of users just basically come to the engine just by the mere show of the graphics fidelity. So no denying that. Uncharted, for the people who love the PS, who love the sort of IP on the PlayStation. Again, it is the work of Naughty Dog, and nobody can deny how Naughty Dog is really, really good when it comes to crafting such detailed, work. Just look at the skin in here. How the beard is showing up, how his chest really responds to light, and the details on the hand and the face, and yeah, just amazing. There's a lot of details. If you're an artist, you're probably freaking out right now more than I do, more than I am here. Okay, so the first thing that we talked about, as we said, is the graphics fidelity. The second thing that really that really makes it important for you to choose a game engine for your game is the capability to go and support massive worlds. Now, this is a very huge deal if you're talking about open world games, things like Metal Gear Solid 5. I know a lot of people have their own thoughts on the the game design and such. However, a game like Metal Gear Solid 5, Horizon Zero Dawn, and God of War now 4, has these games have a lot of details that have to be shown in the game itself as you roam around in the world. So supporting massive worlds is really, really important nowadays. It's no longer, a luxury to be supported. It is actually a must for modern games. And so when we're talking about massive worlds, you have a screenshot here from Naughty Dog again within the game of Uncharted 4 that was released for the PS4. And one of the things that people don't really acknowledge and don't understand in here, and that is, the scenery here in the back is actually a live scenery, meaning if you come down here from the tower and you actually walk in there, you can probably, interact with the objects in there. It's not just a background image. And this is the most important thing to be acknowledged in here. All of these details that you see currently on the screen, they're all live, and you can, as a player, go and interact with them. So it's amazing how a game engine, of course, supported by the hardware, can do that sort of experience where you can just interact with every single thing on the screen. So there you have it. The Rise of Tomb Raider, also a good game by Crystal Dynamics. Big fan of the studio. And again, everything that you see in here on the screen is not just an image, it's actually interactable objects. So you can go ahead and touch them and probably interact with them. So that is the second thing. Now we're going to this third thing here, and the probably one of the most favorite elements of all time is the idea of physics. And so eventually in your game, you're going to have a lot of objects, right? And it's not just placing those objects. You also want to have those objects to interact with each other in the most, let's say, believable way possible. And so in order to do that, the game engine itself has a very specific component that tries to replicate, or let's say that tries to get the engine to behave as real as possible in terms of physics. And so most game engines either implement that in-house, meaning they actually write the exact code that uses Newton rules in order to implement the physics in the game. And some of the studios out there really delegated to other people, so they licensed some of the physics engines out there, and they integrated part of the engine. And a lot of game engines do that. And so a good example is Unreal Engine. So Unreal Engine 4, even though it's a very huge engine, there's a lot of stuff happening in the engine itself. They figured out that, you know what, we're not going to focus on physics. Physics is a very tough area that has already been done better than us. And if you actually go into through the source code, you will see that Unreal Engine really relies on physics, which is the name of the engine by, if I'm not mistaken, NVIDIA. However, if the platform really supports it. But yeah, I just wanted to tell you guys that even the physics in your game has to be implemented somewhere. Somebody has to go and put the actual code that simulates the real physics, the real laws of physics within the game, which gives the game a bit of more dimension when it comes to realism. A good example also is Mad Max by Avalanche Studios. A wonderful game. The way it reacts to the physics of the game, collision, things blowing up, all of that is actually game logic. That supports the physics of that uses the support of the physics engine basically under the hood. So there's a lot to it. Number 4, we have world creation. So far, what we've seen is the basic elements that we normally see when we play a game. We normally witness how amazing the graphics are, how the massive the world is, how the physics reacts, within the game itself. However, there are elements that are also important to the game, the engine, but not a lot of, let's say, attention is happening on that side as gamers. As gamers, most gamers wouldn't know that there's also a missing piece that happens under the hood that only game developers deal with, and that is world creation. So if you're trying to develop a game, there's this sort of world editor that each game engine has their own naming scheme for that, but basically it's a world editor, meaning it's sort of screen where you place objects and you move them around, you create the world as you like, and then you just give it to the game engine. The game engine puts everything within the game and manages all of these resources. So I'll just show you here a couple of examples here. So this is Unreal Engine 4 for the people who are big fans of the Unreal Engine 4. I'll just show you a couple of things in here. For example, you've got the elements here that you can place in the scene. You can put, for example, lights if you want to. If you want, you can put cubes. You can also check out the elements here in the content browser, where you can put 3D graphics, static meshes, animations, a lot of stuff that you can basically put in here. Buildings if you want. And this is this is the exact area where you go and manage the elements within the world. You can move stuff. You can check out how the lighting is operating in here. Also, we have something that we call the scene graph, which essentially is a full list of every single element that you have in your game. And so a game developer is going to have a very close look to the list in here to double check that they're not going over their budget in terms of performance. And the key element here is the more you have stuff on screen, the more the slower your game is going to be. And so you have to be very careful when it comes to putting elements on the screen. Be very conservative when it comes to putting those stuff, just to make sure that you strike this sort of balance of beauty versus performance. And so at the very end here, we have the properties screen, or the details, if you're going with the Unreal Engine's terminology, where you can exactly change the specifics of each element that you put here in the world editor. Things like, let's say, the color of the land, the light color, the size of, let's say, the perimeter of the light that you're putting in there, the direction of the sunlight. All of these things can be modified within this property screen. So as you can probably see, there's a lot to it, and that is not only that, by the way. There's in Unreal Engine, it's an ocean of crazy material. So it is, in my honest opinion, it's a very steep curve to master Unreal Engine. There's a lot to it. You've got animations, you've got stuff that have to do with physics, sound, artificial intelligence. So this is just a very small glimpse of what you can get when you operate with Unreal Engine. And this is the very popular Unity engine that allows a lot of people to develop games for mobile, for web browsers, and also for consoles, in case you did not know. So it's exactly the same principle where you can place things in that virtual world. However, the screen is different. You've got the scene graph in here where you can see all of these elements, and we have this sort of relationship of parent and child where you can put things in. As you move the parent, the son, or in this case, the child is going to move in relation to the parent in the scene graph. You also have all of these resources in here, or the actual content where you can drag and drop into the scene. And last but not least, in the inspector screen, you can go and change those elements. So all of these are fancy state of the art stuff for each game engine. And even while choosing a game engine, you want to make sure that you are very comfortable with the front end and how to exactly use it. And also, there is one element that does not necessarily have a UI for it, which is the pipeline. Now, when you have a game engine, you normally deal with multiple, let's see, various formats of files and media. For example, if you're developing a 3D game, you have 3D assets, you have static meshes, you have also animations, you have skeletons, you have bones, you got a lot of stuff. You've got materials. And all of these things can be developed by different tool sets, different programs. A good example is when you deal with Blender. So Blender is a very popular 3D package that allows you to do static meshes, basically 3D art, and it allows you to do even animations if you want. And so working with Blender, so if you have an artist working with Blender, you want to make sure that the pipeline is very smooth for them when they're developing their content, and in the way you want to transmit it and put it in the game engine eventually, because the game engine eventually is where everything just gets done, and before you basically build the game. But however, those elements, things like creating the music, creating the art, creating the sound, all of these various stuff happening out there have to eventually be in the game engine. And so you want to make sure that the pipeline or the facility, that technical facility that allows you to take the content from those tools into the game engines, into the game engine that you have at your hand, is really suitable and very efficient. And an underline under that word efficient, because you can have a very cool tool, let's say a very cool package that allows you to do a 3D content. However, it might be super difficult for you to move the content from that tool into your game engine. So it's going to be a hassle, it's going to be a nightmare for the game developer working on the game to eventually get those content files. And so, yeah, the game engines out there are working all the time to support those state-of-the-art tools. Things like Blender, 3ds Max, Maya, even tools for audio, for example, Audacity, if I'm not mistaken. And yeah, so all of these tools out there have their own sort of support within state-of-the-art game engines out there. And notably Unreal Engine. So Unreal Engine and Unity represent the majority of the market share for commercial game engines. And they're doing a great job supporting most of the stuff out there. In one way, in order to achieve that, is making sure that we are using standards. So a good example is when you're dealing with Blender, or let's say a 3ds Max, you don't want to operate with a specific format that comes with that specific package. So if you're developing, let's say, content with Maya or 3ds Max, you're not going to ask your 3D animator or your 3D artist to export the files or the content in the format which is proprietary to Maya or Blender in this case. You're going to ask them to, for the most part, export it into what we call an FBX format, which is the standard format for a lot of the 3D content out there. And that sort of file, which has the extension of FBX, contains most of the time the details of the animation, the bones, how they move, and some of the time even these files are going to have the material itself, the colors, the skin tones, all of these things that come with the 3D mesh itself. So what I'm trying to say here, 3D content, among a lot of stuff that game engines do work with, are basically, it's very complicated in nature. It's very complicated formats. These things like 3D animations and such. They're basically layers of content and stuff. And so when you want to import it into a game engine, you want to make sure that you have the right support to get all of these elements. Most of the time, people suffer from, importing the 3D stuff from Blender. However, when they come into the engine, you only get the 3D asset itself without the colors, without the skin tones, without the material, without the depth, the depth of the 3D assets. And so having a proper, pipeline from those 3D packages, among other tools, into the game engine is an ultimate necessity. You can't go without that. And now choosing a game engine, is a pretty big deal. And a lot of focus is actually happening on the pipeline itself. So just be aware of that when you choose game engine. All right, for number 6, cross-platform, which is the holy grail for game developers. Now, if you're developing a game, most of the time you want to support multiple platforms out there, right? You don't want to just build your game and just get it on Android and you're good to go. You also want to support iPhone, iOS, basically, PC, other stuff. But ultimately, for most game developers, they also want to support consoles, game consoles, things like the PS3, PS4, now the PS5, the Xbox. All of these things are interesting for game developers to have their games on. However, it's very difficult to get your game on such platforms because each single platform has their own setup, their own libraries, their own code base. So it becomes super difficult, to allow programmers to program for all of these platforms, the specifics of these platforms. And so the way to go is you just develop your game using one of those engines, and then the engine itself is going to give you a facility that allows it to export to any of those platforms that you have in your hand, which is just beautiful. Which means you only do the job that you only do the job once, and you let the machine, or in this case, the engine does the. You let the engine basically do the rest by just exporting to different platforms and just choosing the specifics. However, it's now way easier to develop for multi-platform consoles, unlike before, where you used to have. So I'll give you a good example. Now, imagine you back in the day where you wanted to do a game on the PS2, which is maybe 20 years back, or 20 years give or take. So supporting the PS2 alongside, let's say, the Xbox, the original Xbox, meant that the developers had to go and actually develop the source code twice, one for each platform, because each platform has its own processor, its own operating system, library. So it was a nightmare to support multiple platforms. This is why only big studios used to afford the ability to go in and support multiple platforms to make money. However, now an indie game developer like myself, or even you guys, can have the chance to develop a game once and just release it on most platforms, maybe with minor modifications for the controls and such. But again, this is just beautiful. Okay, so all in all, now I just gave you a tour on why game engines are very important to the whole thing, and why you, as a developer, would want to go and have a lot of attention, and a lot of, let's say, effort trying to, really do your due diligence when it comes to choosing the right game engine. It's a lot of work because eventually it's gonna be the ultimate ceiling for your, creative vision. And so just remember, a game engine is basically the whole machinery that powers your game engine, or your game, sorry, in this case. Okay, just to summarize, game engines do the low-level, difficult work on your behalf. Now, this is really important because I'll give you an example that a lot of people don't really understand or appreciate. The PS3 used to have a 256 megabytes worth of RAM, which is super little now, super small, as of today. But back in those days, back in 2006, it used to be that game engines, the consoles, um, you know, game consoles had to operate with a limited resources because it makes them very cost effective when people want to buy them basically from the console company. And so compromising on the memory, compromising on the CPU, the processor, and the power, and all of these things makes it very cost effective for players to acquire these game consoles. However, it makes it super difficult for game developers to work with, because just think about it. If you're coming from that age, where we from that era, the PS3 era, you would know that the PS3 used to have just amazing games. Metal Gear Solid 4, Heaven, I forgot the name. What was it? Heavy Rain. A lot of games out there, a lot of titles just just made a lot of memories with us. And when you look at those titles today, you just say, "Wow!" I mean, how did they really pull it off back in those days where you have so little of that RAM and processors that are not really that strong when you compare them to what we have nowadays. And so it's all because the game engine itself takes care of doing a lot of shuffling, a lot of paperwork under the hood without showing it to the player. And it's just basically amazing how a game engine is it's basically like your let me use that analogy. It's basically like your mother in a way. It does all of the stuff for you, and you just don't know about it, and you get things done. Also, game engines define the scope for your game experience. We reiterated on that multiple times. So your game really depends big time on the game engine that you use. Some game engines are really suitable for FPS games, first-person shooters. Some are really good when it comes to platformers. And so when you have a game, let's say vision or a specific game design in mind, you want to make sure that the game engine is aligned with your vision. Otherwise, it might be difficult to go and tweak the engine as you go. Game engines establish a standard pipeline to work for work, and this is really crucial because if you currently deal with people like programmers coming in from Unreal Engine 4, you know any game developer working with the Unreal Engine 4 is going to be able to work on other titles out there, other games, if they are very familiar with the Unreal Engine, because they got used to the pipeline and the way assets are being sent from those game tools. Say in this case, the art packages like Maya and Blender, all the way to the game engine. So establishing a pipeline is very crucial for developers to work on different titles. Otherwise, you're going to be stuck dealing with your specific game engine. It becomes very difficult for you to get acquainted with other game engines out there. So yeah, really great engines out there. Again, you have Unity and Unreal Engine, which are the most popular by far for a lot of reasons. And we're going to talk about those reasons now. And so when you really think about it, when you want to choose a game engine, you want to make sure you have an awesome community, because think about the community as if it was your family. Eventually, you're going to have problems with the code, problems with the product. You want to make sure that you come back and you ask those guys for help. So you want to make sure that the community is already is helpful when it comes to doing this sort of thing, and you want to make sure that they exactly know what they're talking about. I've seen a lot of engines that had a lot of potential. However, the community was not really that big of a thing, and so when you have a problem, when you have things that you want to change, it becomes very difficult for you to get acquainted with the engine, because nobody really gives that much of a damn about your game at the end of the day, and you're stuck on your you're just basically on your own. A good example is Torque 3D. So I actually paid a company that used to have this game engine called Torque 3D and Torque 2D. The name of the company is Garage Games, if I'm not mistaken. Garage Games used to have those game engines out there, and they were one of the first, people to put the game engine code out there for, for a specific amount that you can basically pay those guys. And so it was great, but the problem is, whenever I had an issue with the game engine or actually dealing with my games, nobody used to actually come back to me and help me with these things. And it was not only me; a lot of the people there used to suffer, and so it did not really pick up. Even though the game engine code was nice to work with, and there's a lot of stuff that you can learn, but the community was not there. Also, you need something that is good in terms of support. Game engines might break often because of the complexity, and so you want to make sure that the game engine developer is really fast and quick when it comes to releasing bug fixes, doing support for the code base, and for the features and the requests that you get from the community. So yeah, just be aware of that. You also have to make sure that the game engine that you want to choose has a decent portfolio. Now, Unreal Engine and Unity really picked up because there's a lot of commercial games out there that were based on those two game engines. So Unreal Engine had games like Batman, a lot of stuff. Basically, most of the titles out there are based on either Unity or Unreal Engine. So yeah, just many games. And also, you want to make sure that the engine that you work with is friendly. So you want to be up and running and really in no time. You don't want to spend a lot of time getting used to the engine, and then you basically just do the work, and it becomes difficult to add more developers. And this is why a lot of shift has happened in terms of the philosophy of the game engines out there. So, as I said in the beginning, Unreal Engine was never open in the first place. If you ever witnessed Unreal Engine 3 or even 2, they were private source code bases. And so you had to be an affiliated developer with Epic Games in order to get a copy of the source code and work with the game engine. However, now the philosophy is completely different. You have the code on GitHub. However, there's a twist to it, and as I'll probably show you later down the line. But yeah, all in all, you have access to the source code as a developer. You can see what happens under the hood, how they implement those features out there. And it's not only that; it's just the bar is very low now. It's very easy for developers to get acquainted with Unreal Engine, unlike before. Unreal Engine 3 used to use something called Unreal Script, which was very difficult. It was a proprietary language for Unreal Engine. However, Unreal Engine 4 now utilizes C++, which is a very popular low-level, in a way, low-level programming language, which makes it a great deal. If you're coming from a programming perspective, from a programming background, you can just get acquainted super fast with the engine. And even if you're not a developer, a programmer, you can always just build your game logic using Blueprint, which is the graphics way of just hooking up nodes to each other to achieve the same basically logic. So yeah, there you have it. A lot of reasons for you guys to choose the right game engine. Okay, now the $1,000,000 question is, why would you go and build your own game engine? Meaning, if you've seen the last couple of slides that I showed you guys, we have Unreal Engine, we have Unity, Game Maker, things that cater to 2D games, 3D games, and it becomes very crazy. Why would you go and create your own game engine if there are already a lot of great tools out there that can help you with your content and your vision to be realized? And so there are multiple reasons, but honestly, the most the two biggest factors by far is that some games require different game requirements, and they're not available out there in the market. Now, this was not the case. So this specific line in here was spot on back in the day, because game engines were not really that popular. Each game studio used to have their own code bases, working on their own tools and such. And their game engine code was not built in a way that to accommodate multiple games going further, which means, every time you develop a game, you had to go and pick up pieces from that game and then, work on another game using those, pieces that you picked up. However, as people developed more and more games, they figured out that, hey, you know what? We can create this generic sort of tool set that allows us to go and create games faster, in a much more reliable way, in a standardized pipeline for people to go and create content and such. And so historically, a lot of game developers out there, specifically Naughty Dog, created their own game engines, trying to do their own custom requirements. And one thing to note, Unreal Engine and Unity have really matured, with time back. But if you really think about it, as a console developer, dealing with studios like Naughty Dog, did put a lot of pressure on those developers to create, state-of-the-art features like runtime cinematics, or what we call in-game cinematics, meaning, that sort of a thing that happens as you play the game. All of a sudden, the game shifts to a sort of cutscene, and then all of a sudden you get back to the player and you play without those loading screens happening in between. Well, that sort of a feature is called in-game cinematics, and it's that used to be a very difficult deal. This is why back in the day, you used to have games that abruptly just shut down, the scene and give you a video of some sort, and then that video is done, and you go back to the game, to play the game. But in a way, that used to really, really hurt the immersion of the game. And so with in-game cinematics, you can just feel it as a fluid experience, and you're on the game, with no abrupt, basically, stuff stopping you from, having this sort of momentum on the game. So yeah, different game requirements really dictates what you use in terms of technology and why you want to build your own stuff. Internal quick support. So if you're dealing with a console game that has to be released, for example, on Christmas. You're under tremendous pressure to get that game on time, and so you can't just afford in basically just wait for the game developer that owns the source code to go and release a feature, a bug fix. You might not have that sort of luxury, and so with game engines that are mostly targeting console support like the PS2 and the PS3 back in those times, it was really important that the developer, the game engine development team, it was very important to have them in house within the company itself. So when something goes wrong with the tools, if they break down, you can always just come back to those guys and tell them, "Can you guys fix it?" Yeah. So there you have it. Multiple reasons for people to go and really consider game engines, game in-house game engine development. Okay, cool. So is engine programming a job? Definitely is. I'm going to show you what people do here. Basically, if you are an engine programmer, you are most likely are going to go and put more features in the game engine to support different features needed by your game development team, the people who are basically putting the actual game content. Um, so you might support, let's say, collisions. You might support, as we said, in-game cinematics that allows you to get that sort of immersion in the game. AI support, sound, that sort of 3D sound support, graphics, as we said, physics, even VR, for example, or those AR stuff happening in there. All of these things need somebody that can go, and put the actual logic to support those devices and those experiences out there. So yeah, there you have it. More features require an engine developer to go and add those features. And also, the most important thing by far in commercial games now is the support to maintain platforms that are new and out there. So if we have a new console, let's say the PS5, which is coming up really, really soon, you would want somebody to just take care of the specifics of the PS5 and support it by your favorite engine. You, as a programmer, if you, let's say you're a game developer, a generic game developer focusing on the experience itself, on the game itself, you don't have any experience developing uh, in low level engine sort of support. You don't want to get into this sort of headache of managing the specifics of the PS5, the hardware and the libraries and every single thing. You just want to have the sort of abstraction. You focusing on the game. A game vendor is, somebody like Epic Games or Unity Technologies, focusing on the exact technology for you to realize that vision. And there you go. And so by default, out of the box, you get to have more support for different platforms, and this is really beautiful. I mean, just think about it. You develop a game for Android with a click of a button. You can also ship to not ship, basically build for the iOS, which is, it was never the case before. So there you have it. Okay, so before I chart into the code and show you some of the stuff and I just want to show you the specifics of each layer of the game engine, a bit of theoretical stuff, a few theoretical stuff before we show, the code base here in the last probably 15 or 20 minutes. So there's a lot of math within game engines, physics and software stuff. And so when you have an engine game developer, most of the time you want them to conquer those specific disciplines. You want somebody who's really good with linear algebra, somebody who is really good when it comes to understanding how physics work. And the software aspects are the most important by far, in my honest opinion, because in the end of the day, you're dealing with a huge code base, and there are different elements that eventually have to talk, with each other in a nice fashion. And so you need somebody who knows the way around software to get those things to be glued in the right fashion. Yeah. Okay. So every time you look at those geeks, just remember that these guys are the ones who are allowing you to realize your game, experience and the creative direction that you have. So yeah, a salute for those guys, the geeks out there who are taking care of our technology. All right. So if you are interested in money, let me just tell you that even game engine programmers make a lot of money. When you see them in the spectrum of software development, they almost make 150K a year in the US, which is a lot of money if you are working in the software industry. Normally, people get around 60 to 100K, 60 for juniors or probably 40K. But if you're a senior engine programmer, you can probably get 150K, which is a lot of money for a software developer in the US. So there you got it for the people out there who are interested in the cash. Okay, let's dig a bit deeper here and see the exact elements where we're going to be see them. We're going to be seeing them in action in the actual code here. Okay, now what makes up an engine? How does it work? Can you just show me the exact layers in there? Cool. So this is what I call the engine lasagna. You have multiple elements, within the game engine, and each specific layer takes care of multiple, let's say, responsibilities or duties within the game engine. The first one is going from bottom to top is the utilities and low-level subsystems. Normally, there's a specific layer in each game engine that takes care of very low-level items of the experience, of the game experience. A good example is dealing with math, memory, networking, user input, be it from the controllers, from the mouse, from the keyboard, libraries handling. So all of these things, might not be game specific. However, they're very crucial to having the best experience possible. And so something that I really adore is dealing with memory. So memory is a very important aspect if you're developing a game. Most of the time, you want to make sure that your assets can really fit within the memory or the RAM of the ultimate game console that you're trying to support. So a good example, so to appreciate that sort of thing, if you ever downloaded Metal Gear Solid 4 or just bought the copy, the disc copy, you would know that, if I'm not mistaken, it was on a Blu-ray disc, and so it was probably 40 gigs, 30 gigs, give or take, so 39 or 40 gigs worth of data, which is a lot of data. However, when you have a lot of assets, how can you really give the most amazing experience to those players where you have a lot of content that you have to shove in the game and runtime? And so when a game engine does a pretty good job, handling memory, shifting assets back and forth, this is what we basically call resource management. You get that sort of seamless experience without exactly knowing the limitation of the machine that you have. So there you have it, utilities and low-level subsystems that might not be visible to the player, but eventually, a game engine really relies on heavily to get the job done. When we move up by a single step, we have game-specific subsystems, meaning the stuff that are happening within the game itself. And a good distinction in here is when you talk about utilities and low-level subsystems, it doesn't mean that you always have to use that sort of source code base in a game. You can also just use the first layer in doing, let's say, a VR experience, in doing a 3D, let's say, interactive experience. So there's a lot to it. There's a lot of stuff we can rely or let's say leverage from and this specific layer and use it in other source code bases that we're working on, which is really beautiful. So I'll show you a engine called Banshee 3D. And there's a lot of code base, samples that you can basically pick up and put in your, systems if you are interested in doing different things, even if you're not working on a game, which is just beautiful. And so when we move up the ladder and we go to layer number 2, you have game-specific subsystem, which means in this case we are talking about systems that have a lot of impact on the game experience. A good example is dealing with animation or the render itself, that takes those 3D assets and renders them on the screen in the best way possible, in the fastest way possible. Resource management is exactly what we talked about earlier. However, it is built on top of the memory management layer. And so you've got physics as well, the actual code base that deals with physics and simulation. And then when you go one step further up the ladder, you reach the game editor component. Now, this game editor is not going to be in the finished game. So when you ship your game, you basically ship the game with the first 2 layers that you see here. The utilities, because eventually your game is going to run on the on the final target on the platform that you're supporting, be it the PS4 or the PS3. And the game-specific subsystems, the actual logic, the code logic that gives you that sort of behavior, the animation, the render, they're also very important to the experience. However, the game editor is only needed when you are developing the game experience. It is not needed when you are running the game. This is why when you have game engines, they come with editors. So you can develop your game on your machine, be it a Windows machine or a Mac. You finish your game, you're happy with the debugging, you're happy with how the experience is showing up. You test and you test and you test and you test. And again, remember to test, test, test. And by the end of it, when you publish the game for a target platform, when you ship the game, you don't ship the editor with the game. Now, there's a lot of cases where you want to you ship the editor. Maybe you want to give the chance for the gamers themselves or your players to go and create more content for the game. But in most cases, you only ship the utilities layer and the game specific layer, and you just remove that game editor altogether and just make the game very compact, with those systems along with the content itself, be it the sound, the art, the animations, and every single thing. Yeah. So let's just dig into every single one of those items before we wrap up with the code. Okay, so when we're talking about the lowest level, you have so many elements. So I'm just going to chart those really, really fast, and I'm going to show you how these things are really important for the experience. So nobody can give up math. If you hate math, it might be very difficult for you to join the engine force, the game engine programming team, because there's a lot of stuff happening within your games that really require a good understanding of math. Linear algebra, vectors, if any of you guys remember vectors from university, matrices. There's a lot of math happening under the hood, especially for graphics and other stuff. But yeah, for the most part, graphics. Libraries management is also a very important deal. Normally, when you have a game, you will also deal with different functionalities out there, things that we call libraries. A good example is when you have a game on your machine, on your PC, you have Steam. Now, Steam has a sort of integration that happens with the engine itself. So the lobby for the players, the scoreboard, your friends that are playing in there, connecting them, matchmaking, all of these things might not be supported by the game engine. And so you will need that sort of code integration with things like Steam. And so your game engine has to have that sort of capability to go and work with those, dynamic, basically binaries out there. Things like DLL files or shared object files if it's coming from a Linux background. But eventually, you have components that are shipped by different people that you need to onboard within your game and the runtime so you can benefit from those functionalities. Input and serialization. Now, serialization is a pretty big deal. Not a lot of people acknowledge how this works. Normally, when you work with a game, you have objects on the screen, right? You have a player, you have, let's say, a wall or something. And these things have multiple characteristics, like the location in terms of, the Cartesian 3D coordinate system. And all of these items on screen have different characteristics and attributes. And so in order to play, let's say, a network game and replicate the experience somewhere else far in the globe, in the other side of the world, you want to make sure that you take all of these characteristics and squeeze them in what we call a serialized format, a very compact binary format that we then ship over the network, and then it gets extracted on the other side of the world and rendered on the screen. So there you have it. One of the most important things in network gaming, or even in saving a game. So a good example is when you save a game. What happens under the hood actually is all of these characteristics of the game get saved in a binary format most of the time to not allow people to tamper with the state of the game. For example, giving yourself more health or more abilities. And then that file can be loaded at a later time when the game loads, and then you can have the same state exactly where you left it. So one way for this to happen is like when you have a hibernate or let's say a sleep function in your PC. It basically just takes, not a sleep, sorry, hibernate. Yeah. So in hibernate in Windows, for the sake of example, you take this full content of the memory and you save it in a binary format. You save it on the file system, and then by the time you load your operating system just loads that file and places in the memory, and there you go. You exactly come back to the exact point where you left the machine. Memory management, as we said, a lot to it when it comes to managing memory. A good example that I want to shed some light on is, modern games don't have loading screens for the most part. Yeah, some of them might have those, but for the most part, as you go in a game, your game loads more assets, as you actually go. This is why you see, the HDD or the SSD LED really blinks a lot, because it loads the content, and the game engine just loads the content and it streams it on your screen without you knowing, without even doing it. So one of the cool tricks that game developers use when they're doing their games is that when they, for example, put you in an elevator trying to go from one level to another, most of the time it gives you that feeling that, hey, I'm in an elevator, I'm moving to another stage or another level, but it's actually a trick where game developers try to load more content. And that was the case before because the streaming technology was not at its best. However, nowadays, if you play a game like Uncharted, Horizon Zero Dawn, you have huge, massive worlds, and you never stop to load those things. And you move, and the game engine really predicts that, hey, you're moving there, and it loads more stuff. Network handling also is a pretty big deal. How to send packets, how to avoid lag. Again, there's a lot of code that really realizes all of these things that you see in here, and we're going to have a glimpse in a second. Okay, so I might take more minutes. Probably not finish. I'm not going to finish around 8, maybe 8:10 or 8:15. So you can stick around if you're interested. The second layer is game-specific subsystems. You have things like animations, physics, as we said, rendering, which is pretty crucial to the whole game engine experience. So a good programmer is going to write a good renderer, which allows the game engine to pick up those 3D assets and put them in the game in the best way possible, maintaining the graphics fidelity, but at the same time also striking the performance barrier also. A good thing to really witness in here is script execution. Now, if you remember, old games were very difficult to program because the actual game logic had to be baked within the game engine itself. So there was no separation between the game engine code and the game code itself. So the functionality that allows the game to function used to be exactly, melted down in the same sort of spaghetti code that has the game specific stuff. So imagine your game has bosses, it has, let's say, just basically specific code to your game. How to, basically just bosses and moving on the platforms, collisions, fights, and all of these things. These things had to be exactly baked in within the code base that also manages the memory and everything that we mentioned in here. So the separation was really horrible. It made it very difficult for people to maintain code and such. And so after a while, people created two different systems. The game engine has a very clean interface for people creating game code. This is why we have this sort of separation now in new, let's say, modern game studios. You have people working on the game engine itself, trying to modify it and add more features. And then you have the game developers themselves, the generic people working on the game logic, creating experiences, creating levels, creating, those cool action stuff that happen to you while you're playing your game. But yeah, there's a clear, abstraction between those two levels. And most of the time, a game engine can fix, the engine, add more features without really disturbing, the momentum of those guys who are developing the games, general programmers. Resource management, as we said, shuffling items back and forth without you knowing is really a huge magic, and it's being done on a very low level here. Okay, last but not least, let's talk about the game editor. Some of the stuff here. You have object placement tools, as you can probably see in Unreal Engine. Live reiterating is really important. Back in those days, when you develop a game, you had to run the game from the ground up to check your stuff, if it feels good, if it's amazing. But now you get this sort of live environment where you can run the game, test it out, run the game at the same level, test it out. If you're happy with the values, you go ahead and move to something else. And so even simulating on platforms, imagine you're developing on your Windows machine. You want to simulate developing for the iOS or for Android. You can also do that from the same development machine. You don't have to go and, compile the game, ship it and put it on the machine and try it out. And then if it doesn't work, you have to go and do more changes. And so this is a very seamless experience now. Even the people who are developing for consoles, things like the PS4, the PS5, have a developing kit on the side which connects to your Windows machine. And Visual Studio, or one of those elegant tools, connect to the machine, and it only uses that machine to actually deploy the code and the binaries and run it on your screen. So there's a lot to it, and that sort of integration between the IDE, the game development engine like Unreal Engine or so, and the integration with those new hardware devices coming up is just beautiful. It spares a lot of headache. Also, publishing for multiple platforms, export to different formats, plugin integration. So new things coming up. A good example is Unity. Now, Unity is heavily based on plugins. So a lot of people have plugins that were developed either by in-house or by different vendors. And so at the end of the day, you want your game editor to be modified in a way to add those features so you can develop your game faster or even add more things. I remember back in our game Dead Gear, which you can probably find online. Just write deadgeargame.com, uh, where me and my friend Alex worked on this game for some time. And by the way, it's due for publishing next year, finally, after 7 years. um, that 2D game heavily, we created a lot of, let's say, internal tool set to speed up, the development for our game. And so things that change the menus on Unity, change the inspector menu on the right side, to add just more momentum for developers. So that was really beautiful. Okay, so when we're talking about choosing a game engine, just remember your game engine really decides how you can tackle development problems. Things like open source, massive worlds, streaming if you require that in a game, like level streaming, so no loading screens whatsoever, or open world games, 3D sounds, AI. All of these things really require that you have the right engine for the right job. Okay, let's see what we have here. Let's just see the difference between those two game engines before we look into the code. And I know I'm promising to go to the code soon, but just bear with me. There's a lot that I want to share before we get to the code. Now, there are differences between game engines. So I have a comparison here between Unity and Unreal. Now, Unity is C# based, which means it uses basically the same machinery that powers up the .NET environment. If you are a .NET developer on Windows, it uses the same .NET environment. However, it's not using the .NET framework shipped for Windows. It is using something that we call Mono, which works on Linux, on Windows, or even Mac. Yeah. So Unity is C# based, which means if you develop your game and you ship it, you basically have something that is similar to C# binaries, but they don't work out of the box. They work internally within the engine when you're on the game. Also, we have features like game object.find. If you're a scripter, if you script games within Unity, you know that game object.find is a very cool feature. You can just put the name of the object that you're looking for within the game code, and then you can find it and do things for it against it. You can move it, you can destroy it if you want. The problem with Unity, for myself at least, is that the code is unavailable. I mean, you're bound to work with the engine, but have ultimately no power over the source code. You can't do your own modification. You don't even know how it works on the inside. So yeah, I mean, good luck knowing how things work if you deal with Unity. And it's fair to say that it's easy to reverse engineer Unity's code. Not the game engine itself, but the binaries done by the games. The binaries shipped for the games out there. And so there are a lot of games out there that were done through Unity. You can basically just use a tool like ILSpy to go and look into the actual code and see how it works on the inside. Now, this is really it's a bad thing for developers because most of the time, a lot of people put a lot of effort creating the code base that is perfect for the game. However, it's very easy for people to have a look into the game and know how it works from the inside. Unreal Engine, on the other hand, is C++ based, which means this feature called hard reload loads your code, but it's completely different in terms of implementation when we compare it against Unity. Because you're using C++, there's a lot of linking with DLLs and such. And by the way, it's not very tolerant, which means there are a lot of cases where it can break just the engine, and you will see that the engine that just shut down for whatever reason. Also, even in terms of coding there, if you're writing scripts in C++, you always have to be super careful of what you're writing. A simple mistake in your code, in your script, can really break the whole engine. Your whole engine has to be restarted, which is very annoying, by the way. And this doesn't happen with Unity because of the technology, because of the tech stack and how it's different. You see, with Unity, the game engine itself was built in C++, but the scripting engine where you put the actual logic of the game is done in C#. And so when you break that C# level, in this case, the mono runtime, as we call it, that mono engine is going to break and it can be loaded again. However, the engine, the IDE itself, it's not going to break. It's not going to go anyway. Yeah. But with C++, a simple mistake with a pointer can really, make your day way harder. And last but not really last, source is also visible. So this was never the case with Unreal Engine 3 or 2, but now with Unreal Engine 4, the philosophy is completely different. The source code is out there. You can see how people implement those features, things like VR, AR, even AI, performance code that targets uh, things like certain things in the iOS platform or even in Android. All of these bits, the specifics of the implementation, you can now see them. It's just beautiful. As a programmer, I can always vouch. The thing that really made me to do the switch from Unity to Unreal Engine was the fact that that source code was available now, and I can have this sort of under the hood look and see how things work on the inside. Also, it's very hard to reverse engineer Unreal code because eventually it's C++, which is very difficult to really reverse engineer. If you are interested in understanding how reverse engineering works, you might want to check out one of my talks on Google Meena on YouTube. Just write Ameen reverse engineering, and you're gonna find probably an hour talk showing you how to exactly do reverse engineering or how a software reverse engineer is gonna go and try to break into your code. Okay, so what I'm gonna show you today is the source code of a game engine called Banshee 3D. Now, Banshee 3D was specifically chosen by myself because the implementation is very relevant to Unity. It has the same design elements. It has a C# scripting system. So if you never had the chance to look under the hood, of Unity, Banshee 3D does exactly the same thing, and it has a very good design. So it has a layered sort of design, exactly what I showed you guys in here. You have the utilities, the low-level elements, and then you have another layer handling game-specific code, and then the editor itself, which makes it great for yourself if you're trying to build a product that doesn't necessarily require to have the world editor when you ship the game or ship even a different product that has nothing to do with games. But you can always, just leverage specific layers in your own, design. It is open source. However, now by doing this talk this time around, it is just so sad to say that it was taken from GitHub because the guy who was working on the source code on the project for many years apparently had a lawsuit of some sort. So we're just going to keep it at that. But there's a lot of forks online, a lot of cloned repositories for the the repository before it got shut down there. So you can look into the code and see how it works. So I have the code here. I'll show you where to get it from GitHub. And by the way, it has an amazing and a decent documentation. So there's a lot to it. Even if you don't understand how game engines work all in all, from a theoretical background, you can always go to the code and read those elements and try and understand as you go. Pretty beautiful, and if you ask me. Okay. Whew, finally, we are here. Okay, just give me a second. All righty. First things first, bit of paperwork here. So this is the page of this Banshee 3D engine. It used to be Banshee 3D. Now it completely transformed into what they call BSF, or Banshee framework, which essentially is not the full-fledged engine anymore. It is just those specific components that allow you to create, your game experience. So it's like multiple libraries that can be used within your game engine. So imagine you're interested in having a subsystem that can help you with memory management, streaming, load level streaming. You can also get that library here and embedded within your source code base. So there you have it. Here's the GitHub repository. There's a lot to it on how to compile it, how to see the examples, and you can probably get the same thing just like with Unity 3D. And if we look into into this image, it has a very close look to what Unity has. It has a hierarchy here, or the scene graph, a resource sort of content browser in a way. You have the properties on the spectrum on the right side, and the scene itself where you can place objects. Yeah. Okay. So what I have done here is that I downloaded the code of Banshee 3D, or BSF in this case, and straight out of the box, when you download it, it comes in a format that cannot be opened directly in Visual Studio, and that is for a specific purpose. You see, when you have Visual Studio, this means that you are operating on Windows. However, this guy, whoever created that big source code, was really smart because he figured out that what, maybe people want to use my source code base on other platforms, maybe Linux, maybe Mac. It really doesn't matter for that guy. However, what he went with a system that we call CMake. Now, CMake is a very popular product. Um, what it does is that it allows you to basically choose the source code base that you have, all right, and then you choose a target place where you want to build the code. But it asks you exactly, do you want to have the code ready for a Windows development environment? Do you want to run it on Visual Studio? Do you want to run it on Xcode for the sake of example? And I'll show you exactly how to do it here. uh, but yeah, I just did it before I did this session, and it works like that. When you basically choose the downloaded Git repo here that I have, and I choose another folder for it to create the source code project, when I click on configure, just look at that. It's going to ask me what exactly you want to have as a development environment. You want to have this as a Visual Studio project. You want to have this as InMake for Linux. You want to have that as code blocks for people working with Windows tools, open source tools. You have Sublime on Linux, if I'm not mistaken, Eclipse. So yeah, a lot of tools, and you can even add different things if you want, Xcode and such. It's just wonderful. The second you do finish, you have your project that works specifically for that development environment. And again, this is beautiful. Why? Because you're no longer bound to a specific platform. You don't like Windows? Fine. Nobody's having an issue here with that. You can always have the code and let it work on Linux if you want. So I took the liberty to actually do this in here. And by the time you configure it, there's a lot of work that is being done by CMake to configure the project for you. And it tells you exactly what do you want to put in the source code. Do you want to have support for Banshee plugin, and a lot of technical details that you can find on the documentation page. But however, what I'm trying to show here is that the CMake process makes it very flexible for you to choose the kind of elements that you want to put in your project. You don't need to have the full source code loaded into your development environment. You can specifically choose. A good example is, imagine for the physics, I want to go with physics by NVIDIA, which is the physics engine by NVIDIA. Imagine that I don't want to have physics support in my source code. I can just click on null. Or for graphics, I want to rely on DirectX 11 for the sake of example. I don't want to do this over OpenGL, or I want to use Vulkan, which is new. And so the second you choose all of these settings and you click on generate, your project gets generated, and you can then work with it in your favorite IDE. So I just created those. I just chose all of these settings, and I chose Visual Studio. And there you have it. I have the full Visual Studio project in here. It's not actually a project, it's a solution. And complicated projects have that sort of trend. So Banshee 3D is a solution that has so many stuff in it. It has a FBX loader, which can help in loading FBX content from Blender, from a 3ds Max. GL, the render itself, and OpenGL, if you are interested in knowing how 3D programming happens. The Mono engine itself, exactly what happens in Unity is here, so you can examine how this is implemented. The game editor, see the editor script. So things like how the Unity editor was built, you can see the exact implementation here. It's super cool. So just before we wrap up, I'm just going to take one layer in here, one source project, and show you how it's implemented. So eventually, when you create a project, when you create a solution, there's a sort of dependency among the solution, the projects. So you can easily see that, for example, this solution, Banshee 3D, this project, Banshee 3D, has dependencies on other stuff that you can probably see here on the code. So I just want to show you dependencies, just for the sake of having clarity here. There you have it. So Banshee 3D, the project depends on all of these libraries generated. The other stuff, let's take, for example, BSF Mono. Mono only leverages the BSF library here, and this is a very CMake specific thing. But however, this shows you exactly in the source code, how projects connect with each other. So how the engine itself feeds into other projects that are on top of different layers. So let's just go over the very low level layer that I showed in the very beginning. You remember in the lasagna, you have three layers, the very low level. And you can probably see here under allocators, different pieces, different snippets that have to do with memory management. Check this out. Memory, let's say group allocation here, group alloc. And let me just increase these, just make it a bit bigger so you can have more clarity on the code. So yeah, you see it in here, you can probably see that there's code that is C++ oriented. Of course, you might not know how to deal with C++. However, it's just beautiful how it's being done. And all of these things in here capitalize on modern C++, C++ 17, and the one coming up really, really soon. So how to exactly allocate the memory, how do you allocate it when you don't need it. And sophisticated game engines like those, like Banshee and Unity-like engines, have a lot of choices when it comes to allocating memory. You might want to allocate the memory per frame, for the game. You want to allocate it and just deallocate it by the end of the game. Other sophisticated means for either doing memory management is allocating every single. Okay, so here's one trigger for you guys, because allocating memory is normally a very heavy functionality to be done in the runtime while you are running your game. What most game engines do is that they help you by allocating a huge amount of memory in the beginning of the game. And so when you are trying to allocate, the game engine itself then manages the memory, not the operating system. There's a lot of difference in that. If you imagine you're developing a game, and then you don't really depend on a game engine like that, and you try to allocate more memory in the runtime, you'll find that your game really chugs. It stops every now and then because the operating system has to stop the game thread, get more memory, and then allow your program to run. This is called context switching, basically, or preemptive running. And so with game engines, it does that sort of sophistication where it allocates the full memory for you, and then it gets you, to basically ask for memory from the game engine itself, which is instantaneously. You don't have to go to the operating system. Yeah. So yeah, there you got it. It's just amazing for the memory. We have stuff on animation if you want to see how the animation is loaded, how the frames are being set up. Let me show you something very cool. So even strings, by the way. So even the way you handle strings, even the way you send messages on screen, all of the source code here really takes care of that. And it's beautiful because it's all based on C++. There's a lot to it. And remember, this was done in a way that makes Banshee engine very, let's say, modular, meaning I can just take that BSF file project and use it on my own project without really taking the full editor and everything else in the code base. But yeah, so you have things on the editor. Let's see this side of the code here. So this is the OpenGL renderer. And remember, I chose OpenGL when I did generate the project. But if you do it over DirectX, you're going to find more things coming up in here, the exact source code for DirectX. And so here's the source code that takes care of rendering stuff. So eventually, your assets are going to come in terms of triangles, vertices, and they have to be, automatically maintained by the engine. The engine got to make sure that every asset is in memory when you want to display them. It takes them out away from the memory when something goes wrong or you go into another level. And all of that source code is actually maintained in here. So very complicated stuff like GPU buffers, for example. And that is a good example on how to reserve memory on the graphics chip. So the exact source code is here. And I know there's a lot to it, but I just want to show you that the low level here takes care of a lot of stuff. Sound, how sound operates, allocators, which is the most favorite thing by far for myself. Math. Okay, let's just finish with math before we close up the session. So linear algebra, as we said, is implemented in here. So when you go to BS Math here, Banshee Math CPP, everything from those basically the functions that you find in math and basic stuff here. Let's see. Cosine, dot products. So yeah, there's a lot to it, and if you can actually see how matrices are implemented in here, you can exactly see how they are being done in terms of memory, how the classes are laid out. So yeah, there's a lot to it. I took almost 7 days to read the full source code, and I don't think I'm going to do justice for it now. However, yeah, I just wanted to show you how beautiful it is and how accessible it is for you guys to look on how Unity-like engines are implemented. So yeah, there you go. By the way, you can find the source code in here, GitHub, Game Foundry slash PSF, and you can see the full thing. And there's also multiple copies of the deleted repository. Just write Banshee 3D clone or repository in Google. Okay, so just moving on. Final thoughts before I go away. Game engines define your gaming experience. Always remember that you're limited to what your game engine can provide. Good game engine programmers are very hard to find because there's a diverse set of skills that you have to master if you want to develop, game engine code, and they're pretty much well paid. A lot is happening inside a game engine, as you probably saw, and the source code does a better storytelling, that sort of thing. We will never be able to conquer it within an hour or so. Low level tasks like memory management, input, physics, it's all being handled by the engine, and even the stuff that you find on screen, like from graphics fidelity. If you're interested in reading more, finding more information, I highly recommend. I can't just recommend this enough. Jason Gregory's book. Now, Jason Gregory, in case you did not know, is the lead engine programmer in Naughty Dog. He has a wealth of information on how to lay out the design of the game engine, specific layers, how to do it from a performance point of view, how to do it in an easy software-oriented point of view, how to make the layers work with each other nicely. The book is called Game Engine Architecture. It has now the third edition out there. Very beautiful book. There's a lot of stories from Naughty Dog themselves. They put pieces of code of their game engine, how it really played out within their games, like in Uncharted, in Last of Us. And the second book is Mike McSheffrey's Game Coding Complete, a wonderful book that shows you how to, take care of those important things in the low-level design. And also, Banshee 3D is amazing. I'm not sure if the website is still up and running. However, clones are there on GitHub, and you can check them out. A well-designed engine, I can't stress enough on that. You can learn so much in terms of C++, how to maintain memory, how to do optimized code, how to do it in a way that is very modular. You don't want to work on games. It's very easy to just pick up the last layer and work on other stuff. And yeah, that's pretty much it. Woo! That was a huge marathon. So I hope you really enjoyed this session. There was a lot into it. You can always follow my work at ameenattajer.com or on my handle here, through my handle at ameenattajer. I put a lot of details on game development and artificial intelligence. If you're interested in our products that have to do with artificial intelligence, check out infiniteware.com. And also, we have a product on game development that somehow is mixed up with artificial intelligence. So that is very cool. And yeah, that's it. Thank you very much for having me in here. And thanks, the guys from GDG Jeddah. And now I can open up for questions.
Awesome. It was an awesome session. I loved it.
Thank you very much.
And we can see from the comments as well that the audience loved it as well. Thank you so much, Ameen.
Pleasure.
So yes, Q&A session time.
All right, cool.
So yeah, we have one question.
So this is the source
Okay,
code. Yeah, go for it.
awesome. Yeah, so the first question is, any reason to program your game without an engine?
Um, if you have a very simple game to work with and you don't intend to continue working on other stuff in the future, you might just want to do it once. But to be quite honest, you're going to give yourself a lot of hard time. It's going to be very difficult for you. It's going to give you, because there's a lot of stuff that you have to manage, those low level details. And sometimes you just want to work on the game itself. You don't want to care about how to handle those things. You might as well just leave it to the people who are really proficient with that sort of thing, and just focus on the game itself. But if any of you guys feel like they're very adventurous, they want to do that, go for that. One thing that I really recommend, if you are interested in knowing how games operate on the inside, is that to always create your own game engine, even if it's just primitive. Just go over the whole journey from creating a very simple game engine to appreciate what goes exactly under the hood. So yeah.
Awesome. And the second question is, are there any examples of games developed in Bahrain or GCC?
Of course, of course, of course, of course. So we started the game development in community back in Bahrain around 2012 when he came back from the States. It was called Bahrain Game Developers, or BGD for short. I actually had to focus on the business more back in 2016. So we have two sister communities, Unreal Engine, Unreal Bahrain, by my awesome friend Yusuf Bahazza, and we also have Unity Syndicate by Mun'im and a couple of friends. And so those two communities really spawned from the work that we've done in the beginning back in 2012. And there's a lot to it. When you join in their WhatsApp groups, you'll see a lot of the stuff. But I really urge you to check out Unreal Bahrain here on Google. Yeah, there you got it. So you can see workshops in here. You can see sample demos, if I'm not mistaken. Also, some of the work that people have done back in the past. So yeah, just check it out. Check our work here in Bahrain.
Awesome. Okay, we will wait for 1 minute and for basically for the questions, and then definitely we'll wrap it up. Okay, let the timer start. Less than 1 minute.
Okay. All right, cool. We're doing awesome.
Okay. Okay, so we have a question
Mhm.
which says, is it difficult to go through the process of publishing games?
Well, that used to be the case long time back, to be quite honest. So, if you wanted to develop a game for a console, let's say you wanted to develop a game for the PS3 or the PS2, you actually had to have a really great track record in developing games. And for these people, they give you the development kit, also known as the dev kit, because they were very scarce. And there you actually get access to the console platform owner, documentation, and basically there's a lot of confidentiality spanning the whole thing. So it was not an easy case. But going forward, the whole thing changed, honestly, even the philosophy of the way games are done. So you have indies working on games. You don't necessarily have to work in game development studios, huge game development studios, to create your own games. You can just work on your game from your garage, from your own house, and then just release it. And there are a lot of success stories spanning that space. And so it became much easier. Now there's a very streamlined process to develop games, as NDs, and just give it to people. With Steam now, it's just an easier case uploading your game and asking, just putting it on the store. It was never that case before. So much easier now, thanks to the tools out there and how the whole mentality just shifted in the last couple of years.
Awesome, sounds great. Another question is, why aren't there more GCC Bahraini games on Steam or PS Store?
Okay, so maybe a lot of people don't know exactly that, but there's a lot that goes into making a game. It's not an easy case. So, okay, maybe the engine is taken care of by big players like Unreal Engine and Unity. However, the content itself, there's just a lot of tears and efforts being shed in making a game. So normally you have programmers creating the actual logic in the game, sound designers, graphics artists, people sketching the game, level designers, as we said, environment artists, even AI programmers. So depending on how big your game is and how complicated it is, you know, there's a lot to it, and so it might not be a job for a one-man show. And um, and so this is why a lot of people take a lot of time. I honestly was working on a game with my friend Alex in the US for quite some time, and I was the only programmer. He was the only game designer slash level designer, almost everything else. And we also have a sound designer with us. And so it was a collaborative effort, working in our day jobs and just focusing on the game itself. But that takes a lot of time because you're not doing it full time, and there's a lot of things that have to be accomplished at the end of the day. But yeah, it's difficult, but we are gaining more and more traction. To be quite honest, the government is also, giving a lot of attention to the game development industry now and the scene in Bahrain. I'm super happy to where we've gotten now. I remember starting in 2012, where I booked my first room in Bahrain for game development. We only had maybe 9 or 8 people, and they were all strangers. Nobody knows the other one. And now going forward, we have communities, we have workshops happening all the time, and we had a GCC game development conference back in 2000, I believe, 17 or 18. I actually forgot, where we had developers come from all over the GCC to showcase their work and to talk about the craft. So there you got it. We've come a long way.
Awesome. We have another question from 1 second. Yeah, so we have this question. He's asking for the last link for demos. I
Mhm.
have shared it, Abdurrahman, in the chat, but I will share it one more time.
Okay.
I think he's talking about the repository, right, Abdurrahman?
Yeah, yeah. The repository is there. GitHub/GameFoundry/BSF, or we can just show it in here. So there you got it. Just write BSF, and you're gonna find the first, yeah, BSF by Game Foundry. I think the website is
Awesome.
down. Yeah, but yeah, the code base is here. You can really look it up, and the second you get it on your machine, there's just too much stuff to learn from. So yeah, awesome.
Yep. I've shared the link, Abdurrahman, in the chat. We have another question that says, please
They're
shed
they're
some
coming up
light
now.
on other. Uh-huh. Please shed some light on other field game engines that can be used for other
Mhm.
than making games. Uh-huh.
Okay, so CryEngine, if any of you guys played the game Crisis before, now also got their engine out, and I think it got bought by, got acquired by Amazon, I think. So Amazon has their own game engine. But yeah, there's a lot of varieties, honestly. There's a lot of choices. Um, yeah, I mean, if you just go and write game engine choices for the sake of example, let's see. Yeah, I mean, just the first page in here shows you Unreal Engine is the biggest by far. Things like Gears of War, Mass Effect, Bioshock. Really cool titles out there that really define the experience that you get when you develop a game through that sort of engine. Unity, Game Maker is really cool for 2D games, by the way. Godot is picking up really fast, and yeah, there's a lot of choices. Just look around, just get acquainted, try them for some time. But eventually, if you want my honest opinion, either work with Unity or Unreal Engine, because you also need that sort of support from the community, as we said. Otherwise, you're going to be working on a technology that is not supported by somebody else. It's going to make your life much more difficult.
Indeed, true, true. Another question we have is, have you noticed any trend in the type of games succeeding? What's the best bet?
Okay, so one thing that comes to my mind is that Unreal Engine is very popular for the graphics fidelity. Everyone knows that when you're dealing with graphics with Unreal Engine, you're granted to have this sort of out of the box graphics fidelity. And so it's just beautiful. Even if you're a lousy game designer, yeah, you just might want to go for Unreal Engine for the sake of having that sort of graphics fidelity. And so Yeah, Unreal Engine is very popular for that. Unity is very popular for having an awesome support for mobile phones. And so I remember doing a lot of commercial projects for clients, and it was very easy for me because I used to develop on the Windows on the machine that I used to have, and it's just a matter of connecting it to the iOS through another machine, that has basically a Mac machine, and then just that clicking the button and having that exact executable going to my device with no headache and nothing. Everything is being maintained by the engine. So yeah, my advice: if you're looking for fidelity, you have Unreal Engine, but there's a lot of things that you have to learn. And also, by the way, remember you're going to use C++ for the scripting. You might not be a fan of C++ like myself, but you can always come back and use the blueprint sort of thing, which is that sort of a graphical way of doing game logic. Or in Unity, you can use C Sharp if you're much more familiar with .NET and you find it easier to work with C Sharp code. And Unity is way easier to work with. Anyway, yeah.
Awesome. Okay, we have no more questions, so
Whew.
we'll wrap it up. Yeah, so I've sent now in the chats. One second. Let me
Sure thing.
send this. Yeah, so you can find Amin Al Tajir everywhere on social media platforms, as well as you can find GDG Manama and GDG Jeddah on Twitter, Meetup, Instagram. Uh, yes, that's it for now. And
Yeah.
stay tuned for more awesome events. And stay safe.
Yeah, thank you
Thank
very
you.
much. And you guys have a good day. And again, thank you, GDG Jeddah, for having me. And I'll see you guys soon. Bye bye.
Thank you.